Hi everyone, my name is Wonjun, and today I'm going to demonstrate the program called Social Network Analysis. As you can see, I have two files and another two helper file and one README. So let's take a look before you run this program. So in order to run the program, I have to turn on a new terminal. And since the file is located in a different place, so I have to redirect my files. And then to make sure we're in a same version of the same version of the C++. And here now we can, all right. And as you can see, here's my output of the code. Looks pretty simple. As you can see from here, first user, I used RN, which is my friend. So here I'm generating friend suggestion for the user RN. RN is directly friend with Ahmed, Leaf, and Raj. Um, Using Breadth First Search BFS, the algorithm looks one level deeper at friend of friends, which are usually exactly two hops away. Vanda and Isabella are suggested because they're friends of Ahmad, but they're not already friends with Aaron. This ensures that suggestions are relevant and not duplicates of existing friends. Okay, and here we have the connection path. Next, I find the shortest connection path between two users, RN and Richard. This uses BFS, which is the ideal for finding the shortest path in an unweighted graph. The output shows that RN connects to Richard through Ahmad and Vanda here, as you can see. The degree of separation is 3, meaning it takes 3 friendship connections to link these two users. Here. Yeah, so because BFS explores level by level, it always finds the shortest path. And here is our third part. Now I display connected components of the graph. Um, each connected component represents a separate group where every user can reach out every other users in the group through friendship. For example, user in component 3 form one social community while component 1 and 2 are completely disconnected from it. Okay. This feature is implemented using DFS, which explores all reachable users from a starting point. Okay, connected components help uh, identify isolated community within the network. Okay, okay, most popular user is 3 Ahmad. It's supposed to be show. Oh, here, friends Ahmad with Reg. Here, the graph structure is stored as an adjacency list, where each user maps to a list of their friends. For example, R's adjacency list contains Ahmad, Leaf, and Reg, and adjacency lists are efficient for this type of network because most users only have a few connections. Okay, together this feature shows how graph algorithms can model and analyze a real-world social network. Um, And yeah, the one major challenge I faced during this project was organizing the code across multiple C++ files and making sure the header and implementation files were properly connected, especially these two graph files. So I initially ran into the compilation errors because some functions were declared in the header file but not implemented correctly in the source file. So I overcame this by carefully matching function signatures between helper file and C++ file uh, by reading compiler error message more closely, such as shows up on here. Breakthrough moment for me was realizing how BFS could be reused to solve multiple problems in this project. Once I understood that BFS explores a graph level by level, it became clear how it could be used not only for shortest path, but also for calculating degrees of separation and generating friend suggestions. Adjacency lists are more appropriate uh, than adjacency matrices for this type of problem because social networks are typically sparse. Each user is only connected to a small number of other users. So an adjacency list uses less memory and allows faster access to users' neighbors. And adjacency matrix would waste space and be less efficient for traversal as well. And BFS is ideal for this project because it guarantees the shortest path in an unweighted graph. By exploring the graph one level at a time, BFS ensures that the first time a user is reached, it is through the shortest possible chain of the friendships. So this makes BFS perfect for both shortest path calculations and friendship suggestion based on the friends on friends. Okay, and that's it for it. And thank you for watching and hope you enjoyed it. Bye bye.